Alright guys, today we're going to talk about slope, and the slope of a line is the rate of change between any 2 points on a line. So if you're looking at a graph, the slope is how steep the line is. It could be a positive slope that's increasing, it could be a negative slope that's decreasing, so this would be a negative slope because the line is decreasing. But at any rate, it is a ratio. And it's the ratio of how much change happens in the y-axis over how much change happens in the x-axis. So what that means is, if we were looking at these 2 points on this line, the slope is how many we go up and then how many we go over. So let's say we went up 3 over 4. Our slope is the ratio 3 over 4. Our slope is 3/4. Some different ways you might hear slope talked about. Slope is represented by the lowercase letter m. I have no idea why. Every year I challenge kids to look it up, and nobody comes back with an answer for me. So I don't know if it's out there, but you could look. So m represents slope, and to write this part in an easier way, we use Greek letters called delta, and this represents the change in y over the change in x. We also call slope, just to remember it, rise over run, because it's how many you go up or down over how many you go left or right. So rising here and running here. And then the slope formula is y2 minus y1 over x2 minus x1. And we'll talk a lot more about that a little bit later. Right now we're going to just look at what does slope look like in an actual graph. So up here I showed you that it was how many up, how many over. So it's really important to look at the scale of your grid. So these are all counting by ones, and these are all counting by ones. So we can literally count from this point to this point. How many do we go up? We go up 1, 2, 3, 4. So we went up 4, and we go to the right 2. So our slope is a ratio of 4 over 2, which can be reduced to 2 over 1, but we want to keep our slope in ratio form, because if we just write a slope of 2, that doesn't tell us how many up, how many over. That just looks like 2 up. So I prefer if you write it up 2 over 1. On the next one, again, we look at our scales. They're both counting by 1, so we can count the blocks again. 1, 2, 3 this time over 2. So this slope is 3 over 2. Now, we're talking about a ratio here, so we want to leave these as improper fractions. If we changed this to 1.5, again, just like this one, that does not tell us how steep our line is. up 3 over 2 gives us a really clear indication of how our line functions. And when you're looking at a graph, it goes up 3 the whole way, up 3 over 2 the whole way through. So if this line were extended, it would be up 3 over 2, up 3 over 2, the whole way through the line. Let's look at our last one. On our last one, we're again looking at scales of 1 for both x and y. So we're going up 1, 2, 3, over 1, 2, 3, 4, up 3, over 4, and we have a slope of 3/4. So now we're going to look at finding the slope using just 2 points. You can graph and count, but using the slope formula is going to be a lot faster. So you're going to want to use y2 minus y1 over x2 minus x1. And the way that these labels work is that each coordinate pair is an x value and a y value. And I just call these first ones the 1s and the second group the 2s. So y2 is -2 minus, make sure you get this minus sign in here. y1 is also -2. x2 is 7 minus x1 is 1. So when we're doing the actual formula, we're going to add those, get 0 over 6. 0 divided by 6 is a slope of 0. A slope of 0, if you imagine walking, is just flat land. So the slope of 0 is just flat. It doesn't have any slope. Number 5. So we're going to do y2 minus y1 over x2 minus x1. So we have xy, xy. I call these the 1s and these the 2s. So y2 is 9 minus y1 is 3 over x2 is 2 minus x1 is -1. Notice I got my minus and my negative in there. So now when I solve, 9 minus 3 is 6. 2 minus -1 means plus. I get 6 over 3, which reduces to 2. But I would reduce it to 2 over 1 so that we have a ratio that makes sense. Alright, x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. So we do -6 minus -2 over 3 minus -3. We add, and we get -4 over 6, which would reduce to -2 over 3 for our slope. On the back page, we have some word problems, and they just ask us to graph the data and then find the slope. So I'm looking at my x values, and they're all can fit on the x-axis if I count by 1s. And then my y values, I think I can also count by 1s. and fit them on. This is minutes. This is pages. And we should always be labeling. So I look at this first point is at 0, 0. My next point is at 1, 1.5. My next point is at 3, 4.5. My next point is at 5, 7.5. Let's see. So here's my line. And I can find the slope by going from 0, 0 up 1.5 over 1. And I really don't like decimals inside my fractions, but I know that if I multiplied by 2, top and bottom, I would get 3 over 2, and that looks like a good slope because it's a fraction and there are no decimals in it. So let's look at this next one. Again, if I look at my x's, I can count by ones, maybe even with a space. And then my y-axis has to go from 0 to 405. So maybe I'll count by hundreds, or 50s actually. I'll just label the hundreds. So when I graph, I end up at 0, 0, 1, 135, so a little less than 150, 2, 270, and 3, 405. Now, this one is a little bit more difficult to tell. I always like to start at my 0, 0 point and just go how many up, how many over. So I know that this is up to 135 because that's what my data says. So I know I've gone up 135 and I've gone over 1, and that is a perfect slope. Right there. So if we look at number 6, we have a wheelchair ramp question. The maximum slope is up 1 over 12. So the maximum slope of my line is not very steep. A ramp is designed that is 4 feet high and has a horizontal length of 50 feet. Does this ramp meet the law? So 4 feet high would go with my 1. So if I have 1/12, does up 4 over 50 fit within the limits of the law? So let's check. If the law is up 1 over 12, and we know that we're going up 4 feet, we can solve just a simple proportion to figure out that if I'm going up 4 feet, 4 times 12 is 48 divided by 1, so 48 goes here. So if it has to be 48 by law, would 50 be acceptable? Of course it is. It's just longer. So it is over the expected length. And what can be adjusted on an unacceptable ramp so that it meets the law? So every time you look, you could always make the ramp longer to make sure that it meets the minimum requirements. All right. 7, A, B, C, and D are 4 problems for you to try for homework. Remember, you're doing slope formula, which is y2 minus y1 over x2 minus x1. See if you can figure those slopes out. We'll check them tomorrow. Have a great night.